There are two distinct areas of process control. On the input side, on the output side. You need both, but it's also important to understand which has which function. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today it's about process control. Now, you know process control books and process control systems, quality control systems, statistical process control perhaps. These are all process control, but they have sort of different angles where they attack. And it is important to know the distinction between these two when discussing process control with colleagues or watching videos like these and by other creators. When they talk about process control, they will be usually talking about either in or output control. The thing is, when we have a process, that process has a number of inputs, and you generally get the one output. So output can vary, the inputs can vary, but the thing is, we have a number of things that we need to put into a process to get our result. What type of things do we put into the process? What am I talking about? They are sort of the parameters that we try to fix, and we'll get to that in a bit, that all affect how the process behaves. Things like the settings of the machine, the maintenance status of the parts, training of your operators. So basically this is like the skill level of the operators. How quickly can they react? How well are they able to set those other things to begin with? The materials as well. You need stable materials going in. All of these, they're all things that you want to keep stable. See, when you get the correct settings, proper maintenance, and your people know what to do when they use the materials that are according to specifications, you get this nice output. You get a nice, stable output line. But the thing is, when the process is moving, even when the settings are stable, like you set a specific temperature, you set a specific pressure, the result in the process will always vary a little bit, right? So these are stable, but they give a little bit of variance, and this also gives a little bit of variance. The training is slightly different. The materials, they have a certain range of what they can be, even when you put them in at a specific set point. And because of that, you will get an output that has some variation in it. And that is absolutely normal. That is something we need to deal with. Now, when you look at this input, you see that I didn't pick these words just like that, right? These are the 4 M's, basically. So we have our method, our machine, our man, and our materials. And yes, you can put in the 6 M's if you want, but these are the things you control for the process. Now, when we are talking about process control, too often I sort of see this variation come back. Now, you can put this variation sort of in there if you want it, but I would generally advise against it. If you want to do process control on the input side, fix these, right? These should be set points. So a setting has a set point. There is only one point that you want your operators to put into the machine. One setting. It can change based on the material, but only in a fixed formula. So basically, at any moment, there is only one setting that is correct. There's only one standard operating procedure. Maintenance standards, you can have some decay in the machine. Maintenance is things like the thickness of a roller, right? Or the level of lubrication or something like that. But the thickness of a roller, it should be more than 52 millimeters. So a new roller might be 54 or 56 millimeters, and then there's some wear and tear, and at some point it gets a bit thinner, and as soon as it hits 53, for instance, you put in a maintenance order to make sure that it will be replaced before it hits 52. That too is 1 point, right? The 52. Now, it will create a bit of variation because there's some vibration, some pressure, and the different roller size that we even put into the system. Like a 56 millimeter roller will behave slightly differently than that 53 millimeter roller. So there is some variation, but your control point is 1. Now when we go to the backside, so the output of the process, we have a slightly different way of controlling it. And you sort of know my favorite topic on that side. We do have a range. And if you do that range in an intelligent way, then we are talking about SPC. Statistical process control. But here you will have limits, upper and lower control limit, and you basically do not touch the process as long as it stays within the limits. That is controlling with a range. So the input side, please set point, right? Control based on one value. The output side, that's where you have ranges. Now, why do I make even this video about it? Too often I see that quality control programs, and I suspect that it's mostly to keep auditors happy, not really for the process, they define basically this range here. So they say, well, operators can set the process between 180 and 200 degrees Celsius. But that is not a standard. That is just a way, because you know the alternative. If you say the process should be set at 190 degrees Celsius, and then a auditor comes in, they check the system, it's at 192, you get a minor. You get a remark, you might lose your certification, and that is something the quality department wants to prevent at all costs. So what they say is, it should be set somewhere around 190. But that's not a standard, right? Now, you want to have a set point and a specific instruction when you're allowed to deviate. Don't please some external auditor, please your own processes. And that requires set points. Now, materials, of course, right, they can have specification tolerances. This is definitely a thing, because materials, they are sort of a result of a process already. So here it's okay. They can have a range. But if we're talking about how much of a material to add, again, you should weigh 200 grams of this material. You should weigh 5 kilos of that material. Now, 5 kilos, if that is weighed manually especially, but even automatically, there will always be a little bit of variation in there. So it's okay to have a tolerance range of what gets into the process. It's okay to specify what is actually weighing 5 kilos. So here is the difference, and if you sort of look at this in a more of a mathematical way, you can say if you specify 5 kilos, you would generally accept anything between 4.5 and 5.4. If you specify 5.0 kilograms, you increase the significancy level, right? So now you only accept 4.95 to 5.04. So that's how you do it, and that's why I don't really like when people put into instructions, you should add 5.000, so 3 zeros, kilograms to something. It's like you really want them to be significant up until half a gram. Think about these things, right? There are rules for it that immediately say what is the target. If it is 200, it's always a bit difficult, because you don't really want to write 2.00 hundredths of grams, right? So it's okay to have a bit of a range there, but this is more the measurement error. So that means people can just weigh the 200 grams and be happy if it ends up 196, right? That's something you have to specify. What is the range? The target, however, is 1 point. So it's not you can put in anything between 190 and 200. No, you say you should weigh 200, but it's acceptable to be a bit higher or lower. And the same, well, with settings, honestly, a temperature setting, no. The temperature setting should just be one set point. But if then your machine has a temperature gauge, that one can fluctuate a bit, and that's okay. So here, 1 point, maybe with some slight margin of measurement error. That's basically what it's about, right? On the output side, here we know we have variance, and that's why you have a larger specification range, or even better, a process control range. These are different, and hopefully your process control is tighter than your specification. But we'll talk about that in specific SPC videos or in my SPC course. If you are interested in statistical process control and really want to know how to set up, how to use, how to train others, how the formulas work on that output control, do check out my SPC course. But the main message of this video is input control, one setting, output control, limits, a range. So I hope that that triggered some thought about your own quality management system. If it did, don't forget to hit that like button. Check out my SPC course, and I will catch you in the next video. In the meantime, I wish you the best of luck in your SPC journey. And as always, don't forget to also enjoy the continuous improvement journey.